Mm, right. So this is physics, is it?
Yes. We
Okay.
haven't started doing anything yet for um like any other class, really. So physics is mainly it.
So your classes started which month? This month.
Yeah, we started this week.
Okay. Has the mail gone?
Oh, not yet. I'm still typing.
Have you sent it?
My computer is very slow, so I just pulled it up.
Oh, okay. So is it a PDF file?
They're all screenshots.
How?
Yahoo at .co.in, right?
Yeah.
Okay, I just sent the first half.
So you have any general questions?
Oh, not really. All I did this weekend after
So what is the
learning,
project about?
oh, we're just learning about velocity and time graphs and position time graphs, and that's the unit that we're in. We're in kinematics right now. So
No.
understanding velocity, displacement, distance,
Okay. So what is
velocity.
the project you were saying?
What do you mean? What project?
I thought you sent something like a project.
Oh, that project? That project doesn't need anything. So the way that that project works is if you one of your answers is wrong, in the end you'll be unable to finish it because you have to put all of like the perpendicular bisectors and you have to find like the orthocenter and those different things. So if you find the orthocenter, all the bisectors have to meet at some point, correct? Yes. So because of that, it's very easy to find if you make any mistakes. So because of that, I know that it's right, if that makes sense.
Okay, I've got the screenshots. So is there any sequence?
It should give you the time that I took it. So if you start at like the earliest time, then it goes in order.
Okay, 2.1. So you can see the screen.
Yes.
So this is the first one.
Oh, hold on.
This is starting point.
I have to go back.
So something is cut off. No, x-axis it's not visible for me.
Yes, that is the starting point.
Here
Yes,
x-axis is not visible.
you can, I think if you go to a different picture, if you continue going to different screenshots, you should be able to see it.
Okay.
There you go. You can see part of it.
Okay, so this is 2, 4, 6. Okay, so one division is 1. So find the object position at, yeah. So this is very simple, right? T equal to 2 seconds. 2 seconds is the first division. Again, the graph is cut. So whatever is this Y
It's
reading?
the second division. That's not the first division.
No, this is the question, right?
Yes, but on the graph, it's the second division, not the first division.
Okay, okay, yeah, 1 second, yeah, fine. So here, so it's a
It's
5.
not on a dot.
It's 5, right? No, not 5. 4.5.
Wouldn't you have to solve for the slope and find the
No, you just have to.
the equation?
The position is the
Because it's
y-axis,
not
right?
Yes, but it's not exactly on like a number.
No, 2 seconds. 2 seconds is this line, so it's coming in the middle, right? Middle of this box. So
Yeah.
this is 4, this is 5. So the middle is 4.5.
Okay.
So x1 is 4.5. x2 is at 4, right?
It should be at 7.
So it's 7. And x3 is 13 seconds.
See,
1,
this one, it's not on a
2,
number
3,
either.
4, 5, 6, 7, 8, 10. It's 9. This is 13, right?
But it doesn't touch the 9. It's right underneath it.
Yeah, little bit. It's almost 13. No, almost 9.
Yeah, but it's not exactly on it. It should be 8 point something then.
8, 9, maybe 8.9995. I guess if you put 9, there should not be a problem because it's not. It's maybe 8.9.
It's only asking me for one significant figure. So then if I round up, it shouldn't be an issue.
Oh,
To
okay.
express your answers in meters to one significant figure.
I think one
Then it should
significant.
be
5,
5, 7, 9, or 0. Correct?
I'm not sure. One significant figure means after decimal point, one significant figure or without decimal point?
Without decimal point.
Okay, then it should be 9.
It's correct. It said correct.
And then 17. 17 is where?
0. I already submitted it. That is correct.
17 is here, right? 17 is 8,
Yes.
7.
No, it's all the way down. That's 16. The next one is 17. It's 0.
Okay.
That's it.
Is the answer correct?
Yes, it said correct. Oh, I asked about that other question to my teacher. So apparently, the error question, do you remember?
Yeah.
He said that human error should not be a factor because humans should always try and curb that error and it should not be an issue. So because of that, the only one that would make sense would be the one that was like off by like a couple millimeters, since that is very hard to curb by human error.
No, what is the option that was valid?
Hold on, I can tell you. Okay, so the options were timer accuracy, error resistance, placement of the photo gates, and types of motion. He said timer accuracy doesn't work because the timers go to the 0.00001 and it shouldn't be an issue. Air resistance doesn't work because we want to use friction to find the actual speed and velocity of the cart. And type of motion doesn't work because the acceleration of the cart was not going that fast. So the only one that would work is placement of the photo gates.
Okay. Okay, object speed at these times. So to find the speed, you have to find the slope. You know that relation, right? Speed is dx by dt.
Dx, what is dx?
So how they introduce the speed then? Concept of speed. They would have taught in the class, right?
Yes. Speed is just slope.
Okay, slope. Yeah, right. Slope of position versus time graph.
Yes.
Okay, and slope of a straight line, will it change from point to point?
What do you mean?
Just a minute. See, this is a straight line, right? This part. Okay.
Yes.
How do you find slope of this line?
Slope is 0. There is no slope.
No. What about this line?
Oh, this line? Oh, change in y over change in x.
No, okay, let's first do this 2 seconds. So 2 seconds is here, right?
Yes.
So we have to find the slope of this line.
Yes. That line goes from 0, 0 to 3, 7.
So it's going up by 7 in 3 seconds, right?
Yes.
So 7 by 3.
Wouldn't it be 3 by 7 because it's y over x?
Yeah, y is 7, right?
Yes. It'd be 7 by 3, not 3 by 7.
Yeah. What is the next time instant?
So then would the speed be 7 over 3?
Yeah. At 2 seconds.
That's 2 significant figures.
So that is 2 point something. 2.33.
2.3. Yes. Rounded to 2 sig figs, it'd still be 2.3.
Okay. So what are the next time instant?
4.
4. What is the speed?
Wouldn't it be 0?
Yeah, 0. Horizontal line means the slope is here because it is not climbing up, right? Slope means it should either climb up or climb down. When it is climbing up, the slope is positive. When it is going down, the slope is negative.
And the last one is 13.
13 is here, so it should be this line, right? So it is going down by 1, 2, 3. So 3 vertical distance. So 3 divided by 1, 2,
Negative
3,
4.
4, 5. 3 by 5
Yes.
and minus 3 by 5.
Yes. So it would be negative.
Why is it negative? Because the change in y is minus 3. Because it's final minus initial. Final is less, initial is more. So the change in y will be minus 3 divided by the change in x, that is plus 5.
Any moment of time.
Minus 3 by 5.
Yes, it's correct. It's not minus 3 though. It said that speed can never be negative.
Okay, yeah, speed means you don't have to take the sign, just the value.
Okay.
Velocity means you have to put the sign.
Got it.
So this question is done.
Yes.
So at what moment in time the object can be stationary, moving to right, moving to left, turning around, identify the motion of the object at each time provided. So you just have to see whether it's stationary, moving, and then whether right or left or turning around, identify the motion. Okay, t equal to 11 seconds.
You just have to match it up.
11 seconds, right? So 11 seconds is just here. So
Yes.
11 seconds is what is happening here?
It's turning.
Turning
It's
around, because
moving
before
going
11
left.
seconds the x is increasing, after that x is decreasing.
Yeah.
So it's turning around.
Yes.
What is the next time instant?
Next time instant, 16.
16, what is happening?
16, it's going to the left.
No, what is happening at this? So what is the answer then?
Oh, the slope is decreasing.
Slope is actually increasing. This is more steep, right?
Yes.
So the
But
speed
it's
is,
going to the left because the slope is going down.
yeah, it's going to the left. Here also it's going to the left before 16
Yes.
seconds also. So the speed has increased and it's moving towards the left. What is the next time instant?
11. Oh, we did 11. We did 14. 2.
2.
2
It's moving towards the right.
Yes.
And the speed
And then
is
4.
4, it is at rest.
And then 9. It's going to the left.
No, 9 is here, right? It's going towards right
It's going
only.
to the right. Yes, that's what I meant. Okay, next question.
So this is done.
Yes.
What is the overall displacement delta x of the particle? So what is the overall displacement?
40, right?
This is the final time, right? This is the initial time, 0,
Yes.
and this is the final time. So displacement is changing position. So the final position is x equal to 0. The initial position is x is 0 again.
What?
So the displacement is 0.
Why?
Because see, you're starting from some point, going somewhere, then coming back to the same
Not
point.
this graph. This isn't this graph. This is a different graph. If you go to the
Okay.
next slide, it's a completely different graph.
This is the one.
Yes.
So x-axis is displacement, is it?
X-axis is time. No, yes.
Oh.
X-axis is time.
Yeah, y-axis
Meters.
meters. Okay. So overall displacements. So the final time is 50, right?
Mm-hmm.
So at this 50 time, the displacement is 40. At t equal to the displacement is 10.
That is
So
30.
the position is 10, not displacement. Position. Position is 40 at 50. Position is 10 at 0. So the displacement is the change in position, that is 40 minus 10. That is plus 30.
Yes, that's correct. Okay. What is the average velocity of the particle over time at the interval of change in t is 50 seconds? So we need to find the average velocity of the whole thing.
50 seconds, right? So average velocity is the delta x by delta t.
Yes.
50 seconds. So it is this interval. So delta x is how much?
Delta x is 50.
No, delta t. That is delta t.
Oh, delta x is 30.
Yeah, so 30 divided by
50,
delta
which
t,
is
50. So it's 3 by 5.
Yeah.
3 by 5 is same as 6 by 10.
Mm-hmm.
3 by 5 is same as 6 by 10. So it's 0.6.
What?
0.6.
Yes. What is the instantaneous velocity of v of the particle at t equals 10 seconds? Can you explain how I'd find instantaneous velocity given this graph? Wouldn't it just be the y-intercept?
No.
No.
Instantaneous velocity equal to 10 seconds, right? So 10 seconds is here. See, instantaneous velocity is again the slope of the curve, slope of the xt curve. But the thing is, at 10 seconds means you have to take a small interval at this time surrounding 10 seconds. You know, property of a straight line. See, this is a straight line, right? So if I find slope between these 2 points and say any other 2 points, will it be same or different?
It'll be different.
No, it
it'll
will
be
be
the
same.
same. Sorry, it'll be the same.
That is the property. That is the property of a straight line.
Slope is always the same.
Yeah, that is the property of a straight line.
But also, couldn't I just find the equation of the whole line and then put 10 in, and that would be my instantaneous velocity?
No, if you put 10 for x, no. the equation of straight line will be y equal to x equal to
3
m.
over 5x plus 10. And then if I put 10 in for x, wouldn't I get my instantaneous velocity for that point?
You will get y. You will get the position, right? The equation of this line is x equal to what is the slope here?
3 over 5.
So 3 over 5 into t plus 10.
Yeah.
So if you put t equal to 10, you'll get the value of x. But what you need is the slope, not the value of x.
Okay.
So the slope of this line at this instant is same as the slope of this line.
Yes.
So it's again 3 by 5.
Okay. Yes. Okay. Which of the graphs shows the correct v versus t plot for the motion described in the previous part? That's not the correct question.
During which trial or trials
That's not the correct question.
is object's velocity not constant.
That's not the correct question.
But the figures are correct.
No.
Okay.
Can you not see the correct question? Did it not send?
Oh,
Can you go back one?
this we have done, right?
Yes. Okay. Can I share my screen with you then, since it didn't send?
What about this one?
This isn't the correct question. You're missing a question.
How come?
I don't know. I sent it.
Hold on. I think these are the last two snaps, right? And you send me another mail, second mail.
Yeah, but I don't think it's in the other mail. Hold on. Let me just send you this question.
Okay, I'll just give this screen share. Can you share now?
I just emailed you the question. So you should be able to see it now. I just emailed it to you.
This is second mail, right?
Yes. You see it? Should have green graphs on it. Should be the most recent email I sent you, like right now. Should have one attachment.
You can see the screen.
No.
This is the one, right?
not the right question. I literally just sent you the email. Nope. No.
This is the question.
No.
You only sent 2 mails, right?
No, I sent you 2 more right now.
Yeah.
That one. That one right there.
You can see my screen.
Yes.
This is the one.
Yes.
Which of the graphs shows the correct v versus t for the motion in the previous parts? So this is x versus t, is it?
Yes, the same graph as before.
Okay. So here the velocity is constant.
Yeah, so it should be answer D because the velocity is 0.6 and the time and velocity are constant.
Yeah.
Cool. Great.
You send the you said the same thing twice, is it?
Yes, I just sent it to make sure that you could see the whole graph.
Okay, so then we have done everything then.
No, there's still the second email that I sent you.
Second email sent when? The first, totally I've sent 4 mails, right?
Yes, the second mail. The one after the first one. The one with like
Okay.
10 screenshots.
This one, right?
Yes.
So determine the sign of the position and velocity for the motion in figure 1. Where is figure 1?
That is figure 1 right next to it.
Determine sign of position and velocity. Position is negative because x is 0, x0 is here, right? So all these things are negative. Okay, but velocity is towards the positive x. So position is negative, velocity is positive. So this one.
Hold on.
Understood, right?
Position is negative, velocity is positive, correct?
Position is negative because x equal to 0 is here. So all these values are
Yes.
negative, right?
Yes.
This side is positive. So position is -1, -3, something like that. So position is negative, but velocity is the direction of motion. So the
Yes.
arrow mark is showing towards the positive x. So velocity is positive.
Yes.
Another way to understand positive velocity is x is increasing.
Yes.
Like along this direction, x is increasing from -2 to -1, something like that.
Yes. I have to send you another email. They changed the question. There are figures that you can't see in the previous email.
This one?
Yes, the figure changes.
I think the first question you have sent thrice, right?
Hmm?
This first snap you have sent it thrice.
Yes, the figures where it says figure 2, you have to click it, but you are unable to access the website, so you can't click it. And I didn't realize that.
Okay.
I just sent it to you.
No, now you want to do this one or something else?
I just sent you the updated question. If you check your email,
Okay.
you should. Hopefully.
I think next time you can do screen sharing rather than this one. This thing, if you're
I can screen share now, if that works.
okay, so you do the screen share.
Okay, gotcha. It says host disabled.
Hold on, hold on. Okay, now try.
Okay, can you see it?
Yeah.
Okay.
So an object, this we have done on.
No, we haven't
Okay,
done this.
an object moves along x-axis during 4 separate trials. So y-axis is x. Okay, graphs of position versus time for each trial with same scales on each axis are shown. During which trial the object velocity is constant.
Not constant.
Can you just scroll up? Just scroll this one. Trial A. Here the velocity is constant. Velocity constant means the slope is constant. Here the slope is constant,
Yes.
right?
Exactly.
And
Trial B, the slope is not constant.
yeah, because it's a curve.
Exactly.
Only
Trial C,
straight
it's
line has
not.
only straight line has the property that the slope is constant between any 2
Yes.
points.
Exactly.
One way to understand is to get the slope of this curve, you have to draw a tangent. If you draw a tangent here and the tangent here, the slopes of the tangent are different. But
Yes.
in a straight line, if you draw a tangent at any point,
The slope is always the same.
Okay. Next one. Magnitude of average velocity is largest.
Isn't that where the slope is the greatest?
No, but we have a curve also, right?
Yes.
But you have to find delta V by delta T. So here, trial C, it is 0.
Yes.
Trial 1, can you just then get the number quickly? Or we can just see in terms of divisions. So it's going up by 3 divisions, right? And its
Yes.
x-axis, how many divisions?
3,
1, 2, 3, 4, 5, 6, 7, 8.
7.
So it is 3 by 8.
3. I got 7.
Okay, whatever. 3 by 7 then. So the first one is 3 by 7. And trial C is 0. What about trial D? Go down. So here the slope is going down. So going down by how much? 1, 2, 3, 4, 5, 6, 6, right?
Yes.
So 6 by
7.
same 7, right?
Yes.
So it is 6 by 7. Actually, it's minus 6 by 7.
Yes.
Average velocity, right?
Yeah.
So minus 6 by 7 and okay. And to get for trial B, we have to get the slope of the tangent.
Okay.
But is average means you don't have to, it's not slope of the tangent, it's slope of the chord. Chord is the straight line joining the initial point and the final point. If you join this initial point and the final point, that is a straight line for which you have to find the slope. So this is again going up by 1, 2, 3, 4, 5, 6.
Positive 6/7.
So it is 6 by 7.
Okay.
So I think which one is more? I think 6 by 7 is more.
Yes.
So both B and D are correct. I think it should be D. Oh, okay.
That's correct.
You got this thing, right? Average means you have to, suppose you want to find average between this point and this point, you have to join those 2 points by a straight line. So that will become a
Yeah.
chord.
Yeah.
So you have to get the slope of the chord. Instantaneous velocity is the slope of the tangent. So is it done?
No. Do you not see this question?
Okay. Determine
We
the,
did the first one. We did this one.
yeah,
So when you click figure 2, it changes the figure to this.
yeah.
Do you see that?
Determine the sine of, yes. Here instead of x-axis, we have y-axis.
Yes.
So position is measured in terms of y. Yeah, submitted.
Correct. Okay, figure 3.
Determine the sine of the position velocity of the. It's same, right?
Yeah. Oh, no, it's wrong.
Hold on. Yeah, position is positive. What is the bisected velocity at t equal to 10? So this axis is x, y-axis is x.
Y-axis is x, yes.
Yeah, okay. At t equal to 10 is here. So to get the slope of this line,
Yes. Which is 20 by 50 by 20, which is 5/2.
that is 2.5, right?
Yes. Wouldn't it just be 75?
175. It's
Because
delta y is 50, right? Velocity is slope of the curve. Slope of the curve is delta y by delta x. Delta y is here 50 meters and delta x is 20 seconds. So it is 50 divided by 20. So 5 by 2, 2.5. Twenty-five is here. Yes. $35 is this part. Yeah, you can find it. Delta y is how much?
100.
Actually minus 100. Negative, right? Because it's
Yes.
going down.
10. The velocity can't be negative, can it?
Yeah.
Yes, it can. Can
So
it
minus,
or can it not?
it can be. Because velocity means direction has to be included.
Yes.
So either positive or negative should be put. So 100 divided by 10, so it's minus 10. For how many seconds does the drop moves? So which one is slower speed, the first part or the second part?
The first part.
Because it's less steep, right?
Yes, so it's 8.
Yeah, for how many seconds? 8 seconds.
That's it. There's no assignment. Which vector diagram represents the greatest magnitude of displacement for an object?
Okay, go down.
It's not this one because then it comes back to the same position, correct? D?
Yeah, here the displacement is 0.
Okay.
The first one, the displacement is you have to find this length. What is this length?
What do you mean this length?
Just share the screen. See, displacement is what? The final position. From the initial position, you have to go to the final position, right?
Yeah.
This is the initial position. This is the final
Mhm.
position. So you have to join the initial position to the final position. So this is the displacement.
Yes.
Okay. So this length is how much? Don't
It's
submit it. How much is this length?
root 2.
Yeah, root 2, because it's a square root of 1 square plus 1 square. So this is root
Yes.
2. Here it is 1 displacement.
Yeah.
Here displacement is again 1.
Yes.
So what is the fourth one? Fourth one is 0, right? So
Yeah.
what is the correct option then?
Wouldn't it be? It
What is
could
the
be
question?
second.
What is the question? Greatest magnitude. So it should be 1.
Which one? This one or this one?
First one.
Why?
Because it's root 2, right?
Yes, but this is also the second one is 1 meter.
Root 2 is more or 1 is more?
Root 2.
Root 2 is 1.414.
Yes, that is true. Blocks, 3 blocks.
Yeah, you can draw a small figure. East is means towards north. So 3. Can you draw here?
Yeah, sure.
Or I can draw by myself here.
Okay.
And we can check the answer. So 3 east, right? Yeah, 3 east, 2 north, so 1 west, and 2 blocks south. Yeah, it's very simple then. Yeah, it is 2. Displacement is asking, so 2 towards east, but he's not asking the direction. 2 blocks you have to put east, right?
It doesn't say east. It doesn't say we have to.
Because the final position is 2 blocks east.
Yes.
Okay. Yeah, what is the average speed?
Wouldn't it be?
Average speed is total distance by total time.
Yes, so 60
Total.
kilometers over 4 hours.
Yeah, 60 by 4, that is 30 by 2, that is 15. Yeah. Yeah, I think you can just draw a small figure so that you don't make mistake. So 90 meters north, right? So draw a vertical line upwards. 90, and then 15 seconds, and then turns around. Don't put the same length. It's shorter length, right?
Yeah.
40 means you have to make it shorter line. Yeah. So average velocity is the displacement by time.
Yes, it was the displacement is 50, and the
Yeah.
time is 20.
Yeah.
It'd be this, right?
Yeah. A baseball pitcher throws a fastball 42 meters per second with the batter is 18 meters from the pitcher. How much time does it take? Okay, it's very simple. It's distance by time. So distance by speed. So 18 meters divided by 42. No, I think I'm making a mistake. Time is distance by velocity, right? Distance by speed. Distance is 18 and speed is 42. So it's 18 by 42 is less than 1. 18 by 42 is approximately half. Yeah. 18 by 42 is approximately 20 by 40.
Mm-hmm.
Okay, so it's close, should be close to half. So you should think like this so that you can check whether you're making a mistake or not. Okay, the position of two blocks at successive 0.2 seconds, diameter represented by the number of squares. The blocks are moving towards right. The blocks have symmetry. No, they don't have the same speed. See this second thing, it's traveling equal distance in the 0.2 second interval. But the first one, it's the amount of distance traveling in 0.2 intervals keeps on increasing. So here the velocity is increasing, and here the velocity is constant.
So no.
What are the other options? Yes, sometime during. This could be true.
That's
But
not what I thought.
yeah, because for some, see here it is traveling 1, 2, 3, 4 divisions, right?
Mm-hmm.
4 divisions in that 0.2 seconds. So here also 1, 2, 3. Suppose you take 3 and 4. It's 1, 2, 3, 4. Yeah, 3, 4 interval is same as interval of this bottom ones. So for some time, sometime doing interval 3 and 4. Yeah, 3 and 4 speed is matching with this bottom ones. Yeah, this is simple. This is, you have to do some calculation. So what is the average speed? Definition.
Distance over time.
Total distance by total time.
Yes.
So what is the total distance?
800 kilometers.
And total time? Total time is T1 plus T2.
Yes.
T1 is 400 by 80.
Which is
And T2 is,
and then 4,
yeah, and
so
T2 is 4. So in the class when they are teaching, they what do they teach? They teach the theory part or they solve problems also?
It depends. Sometimes we'll do theory, we usually have to do on our own. And then problems we usually do in class.
Okay, theory means you have to read stuff.
Yes, it's just watching lectures and understanding.
But certain part of theory requires some explanation, right?
Yes.
Okay. Fine. Your toy car moves 0.8 meter in 0.5 seconds at constant velocity. If it continues, how far will it travel? Okay, this is also not difficult. Three seconds from, yeah. 0.8 meters in 0.5 seconds at constant. So 3 seconds means again, this is just one part. So in 1 second, it will cover 1.6.
Yes.
So in 3 seconds, it will cover 4.8.
Okay, that's all I had.
Yeah. Okay, fine. These are very simple ones. Okay. So I think right now they're just starting, right? Starting the. So that's why it is
School
simple.
just started this week, so we'll be doing kinematics and these types of things till the 23rd. That's when I have my first test.
So this physics is AP physics or?
It's AP Physics, yeah.
Okay. Right. So should we close?
Yep, that's it. Thank
Okay,
you.
fine.
I will post this video.
Yeah. So next Saturday, is it?
Yes, next Saturday. That would be great.
Okay. If there is something in between, you can WhatsApp me.
Yes, I will WhatsApp you, definitely.
Okay. Okay then. Okay then. Bye.
Okay, thank you.
Thank you.